Video, we're going to be solving a right triangle, and what that means is we're going to solve for any unknown measures, whether they're side lengths or angles. Before we do that, let's just review our methods for solving right triangles. In order to use a trig equation to find an unknown side length, we need to know at least one side length and one angle measure. And sometimes we got to be specific there because sometimes students want to use this right angle. We can never use that right angle. There's a reason for it. When you get to pre-cal, you define your trig functions. But at this stage, we don't really need to know that. We just need to know that we're not using the right angle. We're using one of the other acute angles here. So we have to know one of those angles and one of those three side lengths in order to find our other side lengths. So that allows us to set up our trig equations. If we know two sides, but we don't need trigonometry, we can just use the Pythagorean theorem to find the third side. Also, if we know two side lengths, we can use what are called inverse trig equations to find our angle measures. Once we've established the measurement of one of those acute angles, well then just to find the other one, we just need to know that those two angles, these two acute angles, are complements of each other. All the angles in a triangle add up to 180. If this is 90 degrees, that must mean that these two angles have to add up to the other 90 degrees. So they are known as complementary angles, and we use the definition of that to find that last angle measure. In a sense, we're just subtracting what we know from 90. So we'll be using each of those methods to solve right triangles. Here we go. Given this right triangle, we're going to solve for all the missing pieces, and we're going to round our answers to the nearest tenth. We're given the hypotenuse, and we're given this angle, so we need to solve for side length BC here and side length AC over here, as well as angle A. Angle A may be the easiest. All you need to do is know that these two angles add up to 90 degrees, so subtract what you know from 90. 90 minus 63 gives us 27 degrees. So no trig needed, just some basic subtraction. We can use that angle if we are confident that we solved it correctly. However, I would always remind students just to use what is given, as those answers are not incorrect. However, if you solve for something and make a mistake and then end up using that piece to solve for something else, you're just making further mistakes. So always use what's given as much as possible. However, if you have confidence in what you're doing, then of course feel free to use the pieces that you've been solving for. All right, let's solve for one of these other side lengths here. BC, for example, could be solved by using cosine. I want to solve for the adjacent side to this angle using the hypotenuse. So I'm going to take the cosine of 63, set it equal to my ratio comparing the adjacent side to the hypotenuse side. To solve for x here algebraically, I just need to undo that division and multiply both sides by 2. So my length is going to be 2 times whatever the cosine of 63 is. Your calculator will do that for you, and it should tell you it's approximately 0.9 units. So side length BC is 0.9. Again, if we are confident that that's correct, we can go ahead and use that to solve for something else. However, remember that we just rounded it, so now we're approximating that side length. If you use an approximated value to solve for something else, well then you're losing accuracy there. And sometimes we want to keep our accuracy as close as possible. So to solve for AC using the two things that I'm given here, I want to solve for the opposite side relative to that angle using the hypotenuse. So opposite and hypotenuse remind me that I'm going to use my sine function to do that. Sine of 63 degrees is going to be equal to opposite over hypotenuse. And once again, we're undoing our division here to solve for x, so we're going to multiply both sides by 2. So AC is 2 times whatever the sine of 63 is. And our calculator does that work and tells us that it's about 1.8. So there we've solved the right triangle. We found all the missing or unknown measures using the information that was given to us. However, the cool thing about solving right triangles is if you have confidence in what you're doing, there's many different ways that you could be solving this triangle. You could start to use parts that you've solved for, and that opens up the door to many possibilities for our solving methods. However, I want to encourage you, until you get confident in what you're doing, use only the pieces that are provided. All right, one more time. Let's take a look at this next triangle. Slightly different in that we're given two side lengths now, and we're not given an angle measure. So knowing that we have two side lengths in a right triangle and we're missing a third side, we can use Pythagorean theorem to find that. In this case, we're missing the hypotenuse. So we know that our hypotenuse squared is equal to the side length squared plus the other side length squared. Or if we're confident in our Pythagorean theorem skills, we can jump straight to this step. The hypotenuse is always the square root of the sum of the squares of your two legs. 12 squared is 144, and 7.7 squared is some number. If we add those values of the squares first, and then square root, that side length is about 14.3 units long. Now that we have the hypotenuse and you feel confident that you did it correctly, you can go ahead and use the hypotenuse in one of these other sides to get your angle measures. Again, we use inverse trig functions or inverse trig equations to get angle measures. So I'm going to continue to use just the information provided to me. Angle A is across from or opposite from this side length and next to or adjacent to this side length. So opposite and adjacent sides remind me to use tangent. So I'm going to use my inverse tangent of that opposite to adjacent ratio, 7.7 over 12, and our calculator does the rest for us, and it tells us our angle measure is about 32.7 degrees. If I'm confident that that's correct, I could go ahead and use the definition of complementary angles, knowing that I just need to subtract what I found from 90 to get that other acute angle measure. However, if you again want to just use the information provided, well, solving for angle B means that we need to change how we label our sides here. So relative to angle B, now this is the opposite side, and this is the adjacent side. So my inverse tangent ratio would be 12 over 7.7 instead. Notice it's just the reciprocal of what we just did. And our calculator should also confirm what that subtraction found before. So once again, we've solved for all the unknown pieces in that right triangle. We've solved the right triangle. And again, not the only way that we could have done this. This is just using the information provided. However, if we start to use pieces that we've solved for, that opens up many more of those methods that we could have used. Hopefully, you're able to use 2 or more methods to get the exact same answer, and that'll let you know that you have the skills to solve a right triangle.